Hello students, I am Suresh Kannan, Assistant Professor from ECE Department. Today we are going to discuss about fiber optic communication. Introduction about fiber optic communication. So before going to fiber optic communication, we have to know about what is communication. So communication is the process of or exchanging of information from one place to another place in the form of optical fiber communication. Here we are using light signal, that is the type of communication in which the light signal is used to carry the information from source to destination, that is called one place to another place. So here the light signal is mainly used for carry the message signal, that is called a low frequency message signal, that is transmitting information optically through the fiber, that is called optical fiber we are using for transmitting and receiving, in between the transmitting and receiving. In wired communication, basically there are four blocks. There are source, transmitter, receiver and destination. In between the transmitter and the receiver, we are using optical fiber cable. This is the block diagram for wired communication. In general, wireless communication we are using high frequency radio signal, that is called RF, radio frequency signal we are using for wireless communication. In case of wired communication, we are using only optical fiber cable, that is called as wired communication. Light is an electromagnetic signal which can be modulated to carry the information. Light is the carrier signal to carry the information. Frequency of optical spectrum is 10 power 11 to 10 power 16 Hz. It can be categorized into three types: infrared 770 nanometer to 106 nanometer. Second type, visible light 390 nanometer to 770 nanometer. Ultraviolet 10 nanometer to 390 nanometer. The light frequency used in optical communication is 1 into 10 power 14 Hz to 4 into 10 power 15 Hz. The spectral bands used for optical fiber communications. There are 6 spectral bands used for optical fiber communication. First one is original band, extended band, short band, convention band, long band and ultra long band. In these spectral bands having the different wavelength with respect to O band to U band, and there are spectral bands with wavelength is 1260 nanometer, that is for original band, 1360 nanometer for extended band, 1460 nanometer for short band, 1530 nanometer for conventional band, 1065 to 1565 to 1625 nanometer is called as long band. 1625 nanometer to 1675 nanometer is ultra long band. So optical fiber, it is a cylindrical dielectric waveguide that operate at optical frequency range. Initially, the waveguide means it confines electromagnetic energy in the surface in the form of light and also guides the light along the axis of the fiber. Structure of the optical fiber. In optical fiber, there are three layers in optical fiber. In first one, core, second one, cladding, third one, external coating or buffer coating. These are the three layers used for optical fiber. In core is the single solid dielectric cylinder of radius A through which we can transmit the optical signal. Core can be a pure silicon material SiO2. So silicon we know about, it is a pure semiconductor device, and SiO2 is the silicon dioxide material. The next layer is cladding. Is mainly used to protect the core, to reduce the scattering loss and increase the mechanical strength of the optical fiber. Cladding is made up of glass material. The next layer is external coating. It is a third type of layer in the structure, which is used to strengthen the optical fiber and mechanically isolate the fiber. So advantages of optical fiber is small size and less weight. The diameter of fiber is much smaller than the other cables. Less storage space is required. Glass or plastic cables are much lighter than the cables. So initially the small size of the optical cable and the weight of the optical cable, both are is small or very less, and the low transmission losses, very less signal attenuation over long distance, and high community to interference and crosstalk. It is free from electromagnetic interference and radio frequency interference. It is not affected by lighting, electricity, etc. No sparking, short circuit. Highly secured signal transmission. It is used for military applications, defense and banking system, etc. And optical fiber is a high environmental immunity, more resistance to environmental variations like weather, high temperature, etc. It is not affected by corrosive liquid and gases. Safe and easy installation with less cost. So cost of the optical fiber system is very less, since it is small size and lightweight, less weight, that is got less weight. It is safer and easy to install. So highly reliable system, because it is one of the more we are using for long duration purpose. That is the lifetime of the optical fiber is about 20 to 30 years. Bandwidth is wide. It is up to 10 power 12 to 10 power 14 hertz. That is several thousand gigahertz. Higher information carrying capacity. So optical fiber carrying higher information. So disadvantages of optical fiber, it is like our initial cost of the installation is very high. Maintenance and repairing cost is very expensive. It is require skilled manpower for optical communication system. Optical fiber are more susceptible to bending and tensile stress than copper cables. So compared to copper cable, optical cable is more susceptible bending and tensile stress. Fiber loss, there are scattering loss, dispersion loss and reflection loss occur during the process of optical fiber. So applications of optical fiber. So it is used in telecommunication system, video control and production switching system. For example, broadcasting TV, cable TV, data transmission and distribution, data communication, for transmitting digital data between CPU and peripherals. CPU means central processing unit with respect to peripheral devices. Computer networking in LAN, local area network, wide area network, metropolitan area network. There are different types of networking applications. It also used in networking for network topology, ring topology, bus topology and tree topology, so etc. Low attenuation, high speed, high bandwidth data applications used for fiber optic communications. Elements of optical fiber system. So we know about the communication having two main block, transmitter and receiver. So in optical communication provide a very high speed data transfer from source to destination through transmitter and receiver. It is widely used for long distance communication with a high degree of reliability and accuracy. So in this optical communication, the light signal can be modulated to carry the original message signal to a longer distance. Here the optical fiber cable is used as the medium to transmit the signal from source to destination. In any communication system, there are three parts are very important. Already we have discussed with the basic communication blocks: transmitter, receiver, and the communication medium. The communication medium, it may be a two type, maybe a wired communication medium or wireless communication medium. So overview of optical communication system. Initially the information source is given to the optical transmitter. Then optical transmitter is passing to the signal through optical devices, that is called optical amplifier, optical fiber, optical coupler, optical devices to the optical receiver. Then we are receiving the signal through optical receiver. So everything, the system based on the transmitter and the receiver through optical signals. Primary elements of the optical fiber communication is optical transmitter, optical source, optical fiber cable, that is the medium of the optical fiber, and the optical receiver is the we are using for photo detector, pin photo detector, avalanche photo detector for optical receiver. Similarly, the transmitter we are using for light emitting diode, laser, that is called light amplification, simulated and radiation. So laser diode, LED diodes are using for transmitter, and additional components we are using for optical devices: cable splicing and the connectors, optical fiber couplers, splitters, optical amplifiers. So these are all the additional components. This is the block diagram or structure of the optical communication system. Overall optical communication system is based on the transmitter, receiver, and the medium, that is called the communication medium in between transmitter and the receiver. So in electrical signal is given to the transmitter. In transmitter there are two blocks. One will be the driver circuit and the light source. And electrical signal is converted into light signal and it is transferred to the optical splice and optical fiber and the regenerator, optical receiver, electronics, and optical transmitter. Then it is transferred to the optical amplifier. At the receiver we are using for photo detector and amplifier and a signal restorer. Then it is converted into electrical signal. So here we are using the transmitter as a light emitting diode and laser diode. Similarly, the receiver we are using photo detector as a pin photo diode and avalanche photo diode. This is the main block diagram for optical communication system. Transmitter, it is having two blocks. A driver circuit, it is used to drive the electrical signal into light source. Light source is electrical to optical conversion can be done by using either LED or laser. LED expansion is light emitting diode. Laser expansion is light amplification, simulated emission and radiation by varying the current flow through the light source. Communication channel, the optical fiber cable is used as a channel. Fiber is made up of glass or plastic material. Repeaters are used for long distance communications to compensate the attenuation loss. We know the losses in fiber, there are different types of losses can be occur: attenuation loss, dispersion loss, bending loss. We are going to reduce the loss during the transmission in long distance. Regenerator or repeater. So in the input of the optical signal to the regenerator is light signal. The light signal is we are receiving at the regenerator and it is can be transmitted into electrical signal. Then electrical signal can be amplified in between the optical receiver and the transmitter. Then it is transferred into optical signal through optical transmitter. It is converted into again light to electrical signal, light signal into electrical signal. In regenerator repeater, it mainly used to compensate the attenuation loss at the particular distance. It contains optical receiver, amplifier, and optical transmitter. This is optical receiver is going to receive the optical signal with attenuation loss. It is converted into the electrical signal, and this electrical signal is amplified using an amplifier. Then amplified signal is converted back into the optical signal. This signal is transmitted through the fiber cable for the next particular distance. This is the main part of the communication medium, which is called as a regenerator or repeater. So repeater, it is input is the optical receiver and output is the optical transmitter. So we know that this is the block diagram of regenerator, which having the optical input and the optical output. In between the optical input and output, we are using an amplifier for electronics by increasing the strength of the weak signal through electrical signals. Electrical signal will be very low frequency signal, it containing low frequency message signal, which is amplified by using the amplifier. The receiver, it consists of a detector, amplifier and a signal restorer. So receiver means we are using for optical receiver at the receiving part. Here we are using optical receiver, detector detect the optical signal and convert into the electrical signal. Photodiode, phototransistor, optocoupler and pin photodiode, avalanche photodiodes are used for detecting the optical signal. Then the electrical signal is amplified to the strengthen the received signal. Restorer is used to restore the signal to its original form at the destination. To protect the glass fiber during the installation and the service, different cable configurations are used. For shorter segments, the cables are pulled through the duct. So in short distance we are using duct method, but in the long distance we are using for underground cables we are using for long distance. Installed longer segments, the cables can be installed either aerial, direct burial or undersea installation of the optical fiber cables. So next we are going to discuss about the optical parameters. So here we are giving some important optical parameters like a critical angle, total internal reflection, acceptance angle, numerical aperture, Snell's law, refractive index, refraction, ray optics. In ray optics there are two types. One is the meridional rays. In meridional ray there are two types, bounded ray and unbounded ray, and skew rays. These are the some of the optical parameters used for optical fiber communications. So in the critical angle is defined as the angle of incident that causes the reflected light to travel along the interface between two different media. So here we are using for critical angle is based on the angle of incident. So angle of incident is we know that the light can be travel along the fiber in the core. So here the diagram representing the critical angle. So at critical angle pi 1 is equal to pi c, at pi 2 is equal to 90 degree. So n1 here, small n1 is represented for core refractive index, small n2 is represented for cladding refractive index. So in this the incident wave and the reflected wave can be used for critical landing, for finding the critical landing angle. So here pi c is represented for finding the critical angle in between the normal line and the reference line. So derive the critical angle using Snell's law. From Snell's law, n1 sine pi 1 equal to n2 sine pi 2. This is the Snell's law. At critical angle pi 1 is equal to pi c and pi 2 is equal to 90 degrees. So here we are substituting the value of pi 1 and pi 2 values in the above equations. Then n1 sine pi c equal to n2 sine 90 degree. So n1 sine pi c equal to n2. Here sine 90 degree equal to 1. So we are using n2 only. Sine pi c equal to n2 divided by n1, and pi c is equal to sine inverse of n2 divided by n1. So this is the value of critical angle for finding the critical angle of fiber optic communication. So next parameter is called as total internal reflection. So when the angle of incident is greater than critical angle, then the light ray is totally reflected back into the more dense medium, that is glass medium. There is no refraction. This is called as definition of total internal reflection. Here we are representing the diagram for total internal reflection is based on the low index cladding, that is called N2 is the refractive index of cladding, N1 is the refractive index of core. So N1 is a high refractive index, N2 is the low refractive index. So by using this, we are going to make the two conditions for total internal reflections. Refractive index N1 greater than N2. Here N1 is the refractive index of core and N2 is the refractive index of cladding. Already we discussed these two parameters. Angle of incident pi 1 is greater than pi c. Here pi c is represented for critical angle. So next we will discuss about acceptance angle. It is represented by pi a, and the light ray enter the fiber at a different angle. We know that light can be traveled inside the core of the optical fiber with long distance. So acceptance angle pi a is entered in between high index core. So pi 1 is greater than pi a. It's the loss of radiation. In order to propagate down the fiber cable, the light ray must incident the core cladding interface at the angle. So here there are various representations for acceptance angle pi a, critical angle pi c, incident angle pi 1, reflector angle pi 2. So next definition of the acceptance angle, it is the maximum angle at which the light ray may enter the fiber axis to propagate down the cable. So pi a, that is called acceptance angle. Maximum acceptance angle is equal to sine inverse of square root of n1 square minus n2 square. Here n1 is refractive index of core, n2 is the refractive index of cladding. So next parameter is the acceptance cone is based on acceptance angle. So the code acceptance angle is the acceptance angle which the light is accepted in the core and travel along the fiber core. So this is the diagrammatical representation of acceptance cone. Here we are using acceptance cone in between the core and the cladding process. So next parameter is the numerical aperture. It is the figure of merit of optical fiber which represent the light gathering capability, that is light collecting capability of the fiber. It is mainly used to measure the magnitude of the light at acceptance angle. The relation between numerical aperture and acceptance angle is given by numerical aperture is equal to sine pi a. Is the formula for relation between numerical aperture and acceptance angle. So numerical aperture is equal to square root of n1 square minus n2 square divided by n0, where n0 is equal to 1, that is called air medium. n1 is the refractive index of core, n2 is the refractive index of cladding. So numerical aperture, it is also represented by n square for core and minus n square for cladding. And acceptance angle is equal to sine inverse of numerical aperture. So numerical aperture depends only on core of the refractive index and the cladding of the refractive indexes. Numerical aperture is also represented by index difference delta. So numerical aperture is equal to n1 square root of 2 delta. It is also represented by square root of n1 square minus n2 square. So delta here represented for index differences is equal to n1 minus n2 by n1. So next we are discuss about Snell's law. It is considered two media with different indexes. Two media, one is the n1 for refractive index, n2 for the glass medium and the air medium. n1 is the glass medium, n2 is the air medium. So here incident ray and the refractor ray and the reflector ray, this depends on the speed of the light. So here the condition is n2 is less than n1. So the boundary interface and the normal line depends on the core and the cladding refractive index. Two conditions for Snell's law: n2 less than n1 and pi 2 greater than pi 1. So when n2 less than n1, the refraction of the light ray at the interface is the result of the difference in the speed of the light into materials. So we know that in Snell's law expression is n1 sin pi 1 is equal to n2 pi sin pi 2 sin pi 2. So from this equation we have to derive the sin pi 1 divided by sin pi 2 is equal to n2 divided by n1 expression. It relates the angle of incident and angle of transmitted wave at the interface of two different media. So next parameter is the refractive index. It is the basic definition or basic parameter of the core and the cladding. It is also called a refraction. It is represented as N, and it is the fundamental parameter of the optical fiber material, which is represented for the amount of reflection in the material. So refractive index is represented by small n, which is capable of the ratio of speed of the light in air divided by speed of the light in medium, that is n is equal to c divided by v. The term c is represented by speed of the light in air is equal to 3 into 10 power 8 meter per second, and v is the speed of the light in the given material. The material may be the air or glass or different kind of silica materials. So here the example for refractive index for air is the n is equal to 1, that is called the refractive index of the air is equal to 1. Similarly, the refractive index of the water is equal to 1.33, and the refractive index of the glass equal to 1.5, and refractive index of the diamond is equal to 2 to 2.5. Similarly, the refractive index of the silicon material is 3.4. So next one, reflection. It is the basic parameter of the light signal. That is, we know that optical theory, the reflection is very basic parameter for light incident ray and light reflected ray. This is the diagram representation of reflection. When a light ray is incident upon a reflective surface at the angle pi 1 from imaginary normal line, the ray will be reflected from the surface at an angle pi 2 from the normal line. Here the pi 1 is the angle of incident and the pi 2 is the angle of reflected. Okay, and the light angle is incident angle at the light strike the surface with respect to the normal line. The law of reflection is stated that pi 1 angle of pi 1 is equal to angle of pi 2, that is angle of incident equal to angle of reflection is called as law of reflection. Next one, refraction. It is the another basic parameter of optical cable, optical light, and the light ray is directly through the unreflected ray, means directly it is passing, and it is refracted for ray with respect to the normal line in air medium and glass medium. In the air medium only incident ray, and in glass medium we are getting a refracted ray. So refraction is the bending of a light ray that is changing the direction at the boundary interface towards the normal line. It occurs when the light ray passes from less dense medium to more dense medium. So here less dense medium for glass and more dense medium is the air. Ray optics. Next one is the next parameter of the optical fiber is ray optics. It is based on the direction of the light ray propagation along the fiber. The exact path of the ray can be determined by the position and angle of ray at which it strikes the fiber core. Ray optics. These are the types of ray optics. One is the meridional ray, second one is the skew ray. In meridional ray there are two types. One is the bounded rays and another one is the unbounded rays. So this is the representation of pictorial representation of the meridional ray, which is enter into the fiber through its axis and across the fiber axis at each reflection. Meridional ray are confined to a single plane of the fiber. It contains the core axis, that is contains the core axis. It is easy to track the path as it travels along the fiber. The meridional ray can be classified as we know that already bounded rays and unbounded rays. So the term bounded ray is propagate along the fiber axis within the core, and unbounded rays are represented by refracted out of the fiber core. So next one, skew ray. It is one of the ray optics concept, and it is not transmitted through the fiber axis and do not cross the axis. It is not a straight line. It is a multiple light can be travel in within the core. Skew ray follow the helical path. It is mainly used for helical path for light traveling method. and along the fiber. These rays are difficult to track the path as they do not lie in a single plane. The helical path changes in direction of 2 gamma at each reflection. Acceptance angle for skew ray is equal to, acceptance angle is represented by pi a, which is equal to sine inverse of numerical aperture divided by cos or gamma. So this is the difference between meridional ray and skew ray. In this, meridional ray confined to a single plane, but in the skew ray it do not confine to a single plane. Means it is the plane which is represented for confined for meridional and non-confined for skew rays. Light to propagate along the fiber axis in meridional ray. Follow the helical path around the core axis is various skew rays. In meridional ray, it crosses the axis at each reflection, but in skew rays, it do not cross the core axis. But easy to track the path in meridional ray and difficult to track the path in skew ray because of helical path in skew rays. So next we are going to discuss about optical modes. So optical modes in general, the light ray propagate along the waveguides as guided electromagnetic waves or guided modes. The mode represent a pattern of electric and magnetic field distribution along the fiber. The number of paths for the light propagation width in the guide optical cable. So this is the optical modes of optical fiber. Depends on the transmitter and receiving port. The optical mode can be varying. So it may be a single mode or multi-mode optical fiber. So next we will discuss about the types of modes in optical fiber. Single mode optical fiber, it is represented by SM, and multi-mode optical fiber is represented by MM. So this is the difference between single mode and multi-mode of optical fiber. In single mode, it has only one path for light propagation. That is, in the diagram representing the direction of light is only one path. And in multi-mode, it has the multiple paths for light propagation. So the light can be traveled at different places in different path. That is called multiple path. And in single mode, it has large information capacity. In multi-mode, have less information capacity due to the multiple path. There is no intermodal dispersion in the single mode, but because of it is only one path in for light propagation, but it has a high intermodal dispersion due to multiple path in multi-mode. So in single mode is the high efficiency due to the only one path. Okay, in multi-mode having low efficiency due to the multiple path. And the laser used for single mode and the LED is used for multi-mode. Laser means we know that light amplification, simulated and emission radiation is called as a laser, is used for straight line, that is called only one path for single mode. And we know that the LED having different types of LED, it may be different colors and different types. Light emitting diodes are used for spreading the light, that is called as multi-mode. And the cost of the laser, it may be a high cost compared to LED, and the diameter of the laser will be narrow, and LED of the diameter is core diameter is longer, that is called, it is not a narrow, it is a wider. For LED is multi-mode system, in multi-mode system. In also the fabrication process is difficult in single mode fiber due to the only one path. For example, laser. Similarly, fabrication process is very simple because it is a cheapest device is the LED. LED is a very low price for multi-mode operations. There is no intermodal dispersion in single mode fiber. In this higher intermodal dispersion due to the multi-mode. So next we are going to discuss about the index profile. Index means the refractive index of the optical cable. So here the optical cable, which is based on three structures. One is the core, and the second one is the cladding, third one is the outer extended layer. So here refractive index of core and the refractive index of cladding we are going to discuss for index profile. In this profile, graphical representation of the variation of refractive indexes across the fiber. So the types of optical fiber based on the variation of refractive indexes. So first one is the step index fiber, it is represented by SIF. Second one is the graded index fiber, it is GIF. And the type of optical fiber is based on the mode, single mode and multi-mode. As we seen in the previous type will be single mode and multi-mode, and another type will be step index fiber and graded index fiber. These two methods, types of fibers used in applications of optical fiber. So next we will discuss about comparison of step index fiber and graded index fiber. So we know that step index fiber in this type is step changes in the refractive index at the core cladding interface. So this is the pictorial representation for step index fiber. Similarly, the graded index fiber varies as a function of radial distance from the center of fiber. So we know that it is the step, means it is 0 or 1 level as a step index fiber N1 and N2. And here graded index means it is based on the radial distance. It is radial part of the system with respect to the core and the cladding. And N1 and greater than N2 for step index change. Next, step index fiber and the graded index fiber can be represented in the form of core and the cladding. So here N0 is the air medium, N1 is the ratio of N1 is the refractive index of the core, N2 is the refractive index of cladding, N0 is the air medium. So it's the difference between step index fiber diagram and the graded index fiber diagram for light traveling paths. And refractive index is uniform through the core, and the refractive index is not uniform within the core for graded index fiber. In step index fiber, it undergoes sudden change at the cladding interface. In graded index fiber, it varies smoothly and continuously changes over the core. So it is the difference between step index and the graded index fiber. The ray of path is only due to the total reflection in step index fiber. In that graded index fiber having traveling oscillatory function due to the radial method. Okay, the step index fiber having coupling efficiency is high compared to graded index fiber. So in step index fiber, numerical aperture is same, and in graded index fiber numerical aperture is not same. That is called as it can continuously changes with respect to the optical fiber axis. Attenuation of the light is less in step index fiber. Attenuation of the light is more in step index fiber. Bandwidth of the step index fiber is 10 to 20 megahertz per kilometer. In bandwidth of the graded index fiber is 1 gigahertz per kilometer. And step index fiber materials used plastic or glass, but in graded index fiber only glass materials is used. And data rate of the step index fiber is slow. In data rate of the graded index fiber is higher compared to step index fiber. And pulse spreading is more for step index fiber. Pulse spreading is less for graded index fiber. And LED is used for light source of step index fiber, and graded index fiber can be two devices are used for LED and laser in the transmitter part. In step index fiber used in subscriber local area network, but in case of graded index fiber, local area network and wide area network both can be used in the graded index fiber. So next we are going to discuss about the optical configuration. So optical configuration, there are three configurations widely used in the optical communication: single mode step index fiber, multi-mode step index fiber, and multi-mode graded index fiber. These three types we are using for optical configuration. And for initially the single mode step index fiber, the core diameter is sufficiently smaller, 8 to 12 micrometer. Similarly, then the light ray propagate is only one path without any intermodal dispersion, IMD. So this is the pictorial representation for single mode step index fiber. Diameter of the core, which is represented by 2A, N1 and N2 is the refractive index of core and the cladding respectively. In single mode step index fiber, uniform refractive index width in the core diameter, it has only one light propagation path. It has large information capacity. There is no intermodal dispersion. It is widely used in many applications for a single mode step index fiber. In advantages of single mode step index fiber, due to the low internal dispersion, it can be widely used for very long distance transmission. It provides maximum information capacity. Dominant fibers used in telecommunication and networking. So next we will be discuss about the multi-mode step index fiber. So this is pictorial representation for multi-mode step index fiber, which is used for multiple path of the light travel. The N1 greater than N2 is represented for refractive index of the core and the cladding. In multi-mode fiber, the core diameter is longer than the single mode fiber, that is 50 to 200 micrometer. The large aperture area allows more light to enter the cable. It has multiple paths to propagate within the core. In this step index is used, that means the light signal with uniform refractive index is given to this fiber cable. The light ray are propagated down the core in zigzag manner using the total internal reflection principle. So these advantages of the multi-mode fiber. The right ray are continuously reflected towards the center of the core at different angles and length. It limits the overall bandwidth. It is used for short distance applications. So thank you for your contribution.